All right, so we're going to be discussing the rate and stoichiometry right now. So rate is the rate of change of concentration over time, and stoichiometry here is just the ratio of reactants and products. And so to do this, what we're talking about is when you have a chemical reaction like this, then if you were able to plot out all of the data, you would notice that chemicals that have the same coefficients, such as NO and NO2, have complementary rates. If in fact they'll have equal rates, except maybe a decomposition and formation. So here we have a rate of formation, and a rate of consumption. And the rates are equal but opposite. If we compare these to the rate of consumption for the oxygen, we notice that the rate of consumption for the oxygen is half that rate. And I know this isn't quite as convincing, but if you drop in a line here like so, then you can actually compare you could compare angles even if you wanted, if you're a real math head. You can compare the angles. You can notice that the angle formation and consumption are equal for the two that have the same coefficient, and they are about half for the one that has half the coefficient, half the coefficient, or half the rate. Okay, so what I wrote here is that stoichiometry of a reaction has a direct effect on the rate of formation and the consumption of the reactants and products. This is due to the conservation of matter. The rate at which one form of matter is changing must be equivalent to the forms it's changing into. You can't be losing and gaining any matter. You have to start with a certain amount of matter and you have to end with it, and the way that you're reorganizing the matter is what's described in the stoichiometry. So we can play around with this a lot. There's lots of fun things you can do, but if you know the ratio, then you know the ratio of rates. So if we know that the ratio of NO2 is 2 to 1 with oxygen, so here's our NO2 and oxygen, then we will know that if we can measure the rate of NO2 right here, then the rate of oxygen must be half of that. It gets a little more complicated if the ratios are not so clean. Ratios of 2 and 1 are very straightforward, but ratios of 2 to 3 is a little bit more complicated. So let's just maybe redo this question right now. Well, maybe not all of that. So what I've done here is I said, okay, I want to know the rate of C. I know that the rate of A is 0.6 molarity per second. So I'm going to multiply it by the ratio of C to A. I'll always put what I want on top with what I have on the bottom. So 3 over 2. Dividing by 2, I get 6 divided by 2, which is 0.3. 0.3 times 3 is 0.9. And so that becomes the ratio. You can do the same thing down here with scientific notation. If the numbers are the same, so 2 and 2, then the values will be the same. If the numbers are of different ratios, then the value will be different, and it will be different by that ratio. So we essentially did, for this question, we did 1.1 times 10 to the negative 8 molarity per minute times the ratio of 1 chlorine over 2 NOCl. What I have over what I want over what I have.